Today we will learn about selective protection of primary alcohol groups. In earlier classes, we have learned about the protecting groups of alcohol functional groups, OH groups. And we know that the important protecting groups of alcohol functional groups are silyl protecting groups. And we have learned so many silyl protecting groups such as TMS, which is trimethyl CS3, CS3, CS3. This is trimethyl silyl protecting group. So this is how an alcohol group is protected with the trimethyl silyl group. And then TBDMS, tertiary butyl, that means tertiary butyl dimethyl silyl protecting groups. This is how it is protected. Then TBDPS, that is tertiary butyl diphenyl silyl protecting groups. That means silicon phenyl group, diphenyl group, and then see tertiary butyl diphenyl silyl protecting group. This we have learned in the earlier class. And also we know that when we use F minus fluoride, that is for example tetrabutyl ammonium fluoride, TBAF, tetrabutyl BU4, tetrabutyl ammonium fluoride, NH4 plus F minus. This will be easily deprotected. F minus can attack here and it will show RO minus. So these things we have learned earlier. My question is, how we can selectively protect a primary alcohol group? That is the question. How we can selectively protect the primary alcohol group? I will explain with an example. This is a nucleoside, and you know, deoxyadenosine. This is a very important molecule from which many biologically important molecules are being synthesized. Suppose we have to oxidize this OH group, only this OH group. Okay. Suppose we have to. So if I ask a student who learned organic reagents, can answer yes, if you add a Desmartin reagent, or if you add a KMNF or any oxidizing agent, you can oxidize this molecule. Okay, the answer will be this is adenosine. Okay, so oxidizing agent. So if I add an oxidizing agent, will it happen? Yes, it will happen, but the thing is that this also will happen. This OH also will be oxidized. So what I have to do is, in order to oxidize this only this OH group, what I have to do is, I have to first protect this OH group. So protect means I have to selectively protect this primary alcohol, not this secondary alcohol. That is the thing I have to do. Okay, so for that, this stands for adenine. So this is deoxyadenosine. Okay, for that we have to protect this primary alcohol. So I use TBDPS. That is phenyl tertiary butyl silyl chloride, TBDPSCl, in presence of, for example, pyridine, a base. Tertiary butyl diphenyl silyl chloride, TBDPSCl, in presence of pyridine. So what happens if I use TBDPSCl? What happens? You see, by comparing it with TMS, trimethyl chloride. It is little bit bigger. It is sterically much bigger, sterically hindered. So it is bigger. So it will not go to this OH group, secondary OH group, because secondary OH is in a sterically hindered position compared to primary OH group. So a big molecule will approach only to this primary OH group. This bigger silyl chloride, the TBDPSCl, will not go here, it will come here. So in presence of base, this O lone pair will attack here and Cl goes. See, it will attack here and Cl goes. What happens? You get O, TBDPS O, and this OH will be free. And now you can oxidize this OH group to a carbonyl group, and then after oxidation you can cleave this with a fluoride ion. So this OH will be free. Then this OH will be oxidized. This is how we can selectively protect this OH group in presence of a primary OH group in presence of a secondary OH group. Thank you.